Hello, hello. Are we live? I think so. So, back again. Was just here a few hours ago, and we're counting down to day 7. So, I think I'm just gonna hang out for a while. Yeah, if you're watching this later on YouTube, just skip to about the 10-minute mark in the video, and that's when the puzzle will go live, and I'll get started. So until then, All right. Is this thing still on? Reactivate my camera. Here I am. Is my mic still working? Cool. Less than 2 minutes to go. Ready to run my input downloader. Minute and a half. I don't have anything to say. I'm just going to sit here in silence for 80 seconds. Callie's here. Maybe she won't freak out as much streaming at midnight compared to streaming at 7 p.m. Dinner is like 8:30 p.m. for her, so around 7 p.m. she's getting hungry, and she wants me to know about it. Right now, I think she'll be calmer. She already ate. Fully charged, ready to go. It's almost time. Hopefully I can finish in time to watch some other streamers. Doubtful. I'm probably going to be pretty slow. Okay, I'm in. Input is downloaded. I have my input. And I have my template. Let me get the test input. Nine lines of test input. Okay. Don't need a log file. So that's the test input. What's this about? So we have an equation. We have, only add or multiply. It's not too many operators. Oh, left to right. Okay. So we have like a string of numbers or a vector or a list of numbers, and we have to try basically every possible permutation of additions and multiplications to see if we can come up with this number. Part one, I understand it. The trick is just iterating over binary numbers and converting those to operators. I have bitwise operators in syntran now, so this might actually be helpful because I can just iterate through integers and then extract bits. Yeah. Yeah, I can do that. That should really help here, because then I don't have to like convert the number to binary or convert it to like a vector of booleans or a vector of ones and zeros or anything like that. Okay. How big is the input? I think I've got this, 850, and we've got around 10 numbers per line. Oh god. Oh, we're gonna need 64-bit integers, right? 19 billion. Yeah, that's gonna need to be 64-bit. Okay, that's not a major complication. Just have to be aware of it, and maybe I'll forget, and maybe I'll get hung up on that later. So this is day 7. All right. So what am I even parsing? So we're going to have a line. We're first going to split it based on semicolon, and then we're going to split the rest of it by spaces and parse out integers on either side of those delimiters. Yeah. Or you can parse it into one list and then just treat the first entry specially, but that feels sloppy. I think I don't really need to save anything. I can just iterate on this one line at a time. So we're going to have strings equals split. So we're going to split this string into multiple strings based on the colon delimiter. And then we have an answer on like the left side of the colon. Parse I32 strings 0. And then let's do V for a vector. That's what I usually do. And this is going to be delimited. Oh, and I should be using 64-bit. So this is strings 1 after the semicolon. So anywhere I have a 32, I want to be careful that that's 64-bit. Let's see if I print that. Right, I need the delimiters, which is just spaces. The first one, the answer, I'm only parsing one number, so there's no delimiter. Okay. Last one, 292. I think I got that. All right, now we're going to iterate through every possible permutation of plus and mul, add and mul, addition and multiplication. So if we have a 0 in a certain bit, we're going to add. If we have a 1, we're going to multiply. You could do it the other way around. I'm going to try to move fast here and maybe not talk too much. So we have to know how far up do we iterate. And that's going to depend on how big V is. And then we're going to iterate up to 2 to the power of NV. And then we might be able to break out of this. Yeah, if we find something that matches, then we might be able to break out of this loop early. If it's one of the impossible equations, then we iterate through all of them and we just never find anything. So we're going to have a result, and we're going to sum things up. This goes through permutations. We're also going to need an inner loop to iterate through the numbers in the vector. 2 to NV. I think it's actually 2 to NV minus 1, because we have one less operator than numbers. Okay, no, I think we only need one loop. So up bit is going to be 1 bitwise and with I. What am I doing here? We want like we want a bit of I. No, I do need an inner loop. This one This one can go 1 up to NV, and then we're going to have 2 numbers out of the vector. Now, this needs to be up here. J minus 1, because we start at J1, so we want vector 0 for the first iteration at least. And then we're going to do some operation on these 2 numbers. And we're going to add... No. Res starts out as V0. Do we want to shift... Do we want to shift I by J or shift J by I? I think we want to shift I by J. And then get the lowest bit, so that's why we end it with 1. And then, if op bit, it can either be 0 or 1, because we're extracting 1 bit. I don't think I need braces here. So we're going to do res plus equals VB. This is times equals. And then outside of the J loop, if res is the expected answer, then we add it up. That didn't work. I-64. That seems too big. That's way too big. But we didn't get 0, so that's weird. Oh. No, that's really weird. There might be more than one way that you can build that sum, and then we have to break early. Is it still? What the hell? So what am I adding up? Sum is I-64. $292. $32.67. No, I missed one. So this one should have worked with multiplications. And why didn't that work? Why did we not multiply these? So I'm failing on the very first one. What if it's just that? That's not right either. just leave early after the first one, because why is this not working? Am I iterating this loop, and then am I iterating the other loop? It's 1, but we should have, yeah, 1 makes sense. So we're adding them both times because we do 2 permutations. We have 2 iterations there. Is it because I'm starting at 1? There we go. Okay. So $37.49. A lot of logging. I think I have to kill some of this logging. Why not? Hey, that was pretty fast. I moved like as fast as I possibly could. Third type of operator. Damn, I can't bit shift now because we have base 3. So I need like a convert to base 3 operation, and I have to roll that myself. What the hell was this printing? I still had this. Took a second, not bad. Okay. So let's take part 1, copy it. That's going to become part 2. Okay, so I need a way to convert a number to base 3. Base 3, number, 64-bit. Is it actually 64-bit? What am I going to convert? I'm going to convert I. Yeah, it should be 64-bit. And this is going to return a vector of integers. I guess they might as well be 64-bit. 32 would definitely work, but it's just going to be easier to not have to convert everything. So each element of this vector is going to be one part of a base 3 number, one digit. Can you call it a digit if it's base 3, I guess? And then I have to look this up. It's some combination of integer division and maybe modulo. It's general, regardless of the base, really. Base 3 algorithm. Look up the base 2 algorithm. Is this cheating? I don't know. Like, So you get n and the remainder. So div mod remainder. Okay. And what's the biggest number of bits that I could have? Let's just make it 64-bit. 64 triplets, 64 trits. I don't know. What the hell do you call these? I think that has to be 64-bit. It's a vector of 64-bit integers that's 64 elements long. Okay, so doesn't really matter which endianness we use. We just need all the permutations, so that does not matter at all. Let's just brute force it. Let's go all the way up to 64. You won't have to go that high. You need fewer trits compared to a 64-bit binary number. And mod 3. And then divide equals 3. And then about res. And then res I equals r. Is that it? Does that compile? No, because n is nothing. It's not n, it's a in mine. Come on. I feel like this might not be that bad. Okay, that interprets at least. Let's go back to the test input. I don't know if you need this early return check. I'm just copying questionable code from Stack Overflow. Okay, then we're going to need to call that thing. Don't need that taking up my background. You can look at my mountain landscape. So we're going to convert I to base 3. Does that work at least? I don't call part 2. Okay. Looks plausible. All zeros, we get a 1. Shouldn't there be a 2? Oh, right, I have to loop up to 3 to the power now. So that's a 3. Do I have any other 2s? I don't think so. Think of how much time I waste scrolling. So you have 0, 1, there should be a 2. I'll say, all right, I got the answer. So it returns early. right? And I still have this logic in there. But you can see I get like some permutation of zeros, ones, and twos. Sometimes I get all twos when I loop up to everything. So that seems correct. Okay, I hope. Let's not print that. Now, instead of getting the op bit like this from part 1, op bit is just going to be part of I3. It's going to be the jth trit of I3. I don't know if trit is the right word, but I think you know what I mean. And then we have to implement the concatenation operator. I can do that in syntran. It's not terrible. So we're going to have an extra case, else, and this is done in base 10. So stop worrying about base 3. We're going to concatenate in base 10, 15, 6. Res equals parse I64, and we're going to parse a string, which is string res plus string VB. I think that's how to do that. 3751? That's not right. Is that part 1? Am I editing part 1? Nope, that's part 2. J-1, god damn it. I should have written the loop differently from 0 to NV-1, and then this would just be J plus 1. 11387, okay. Cross your fingers. I've got a good feeling. I understand the problem, I think. Oh god, is this really that slow? Why is it printing base 3? Oh, it prints that one. It's pretty slow though. How many numbers do I have? 850. I don't think this is going fast enough. Well, I think I'm just gonna wait. Bad cop doing this. Bad cop done already? I have no idea which iteration I'm on. Every time it hits a 0, which is the first permutation of base 3 numbers, it prints one of these, but they all look the same. I don't know. Should I race myself? See if I can speed this up. What's like the biggest string of numbers that we have? Probably not more than like 20. And then I don't want to print that. But maybe I want to print Okay, this one's 10% of the way done because we have 800 some numbers. 850. So this one's 10% of the way there. I have no idea what the progress is on the left. I just sped up my base 3 converter by a factor of 3 by assuming that I'm never going to have a very large number. Quarter of the way done. Some move faster than others because if it finds an answer, it can break out of that loop. Who else is twitching this right now? I think I saw Raython. Tej. I saw Tej had a YouTube title, something about Advent of Code in NeoVim. But NeoVim uses Lua as a config, so he's not just doing Advent of Code in Lua, is he? Ryan is doing Advent of Code. Did he switch to C#? Looks like this might be halfway there. Even 20 is probably too big. I think 10 might work. I didn't actually count the longest number there. I could have just logged that easily. Come on. Every once in a while it makes a big jump, like it gets a bunch of numbers in a row that quickly sum up to the right answer. Or not necessarily sum up, but operate up. I hope this is right. I really don't want to stay up too late. It's 12:30 for me. I'm on the east coast of the US. All right, that one won the race. All right, that wasn't too bad. This is exactly what Bad Cop did yesterday, racing 2 different implementations. Ideally, you would pass this to the base 3 converter so that base 3 knows it only has to go up to that many bits. Or the other way you could do it is you check which power of 3, what's the smallest power of 3 that's greater than this input number, and then that's like the number of output digits that you can need. And then you don't have to like brute force loop up to 20 every time. But yeah, you know what? I got an answer. It was right. I'll take it. Let's check out the leaderboards. Oh, I was down here with Kuvi Man. I think Kuvi Man is probably another East Coaster, you know, somebody in an inconvenient time zone where you don't want to stay up that late. And I can't blame people. That's me. This is like the one exception where I've stayed up to the release time of the puzzle. So I jumped ahead of a few people. Good game, guys. I'm sure those people will pass me up in the next few days when it's not the weekend and I'm not able to stay up this late. How do you see, like, times? It's probably stats. Yeah. Personal times. Okay. 30. Well, of course it's my best day yet because, well, day 1, I did better than day 1 because I was moving as fast as possible. I didn't spend too much time explaining what I was doing. Part 1 was much better than I did on day 1. Part 2, just barely edged myself out. All right. Yeah, I guess I'll raid Ryan. Because he might be the only other AOCer that I see right now. Rython Dev. All right, thanks to anybody. Oh, I didn't even commit. Well, you'll see the commit on GitHub. It's late. I'm tired. I don't want to be streaming that long. So thanks to everybody who tuned in. I will catch you next time. Bye.
Oh, Jeff, thank you so much for the raid. I really appreciate it. I do not know. Okay, wait, I heard the TPS. Thank you so much for the raid. I really appreciate it. Welcome in, everyone. My name is Ryan. I'm a co-writer and study streamer based in Malaysia. Today we're doing AOC Day 6, Part 2. And if you don't know me, I'm known for creating this task widget right here. I also have other projects such as the Coaching Stream Guide website. If you're interested in that, then check out Estimation Mark Guide. If you're interested in using the task list in my channel right now, you can do Estimation Mark Task Help. For example, I can see my current focus task is AOC Day 6. And I can do other things like